All right, in our next video, let's see how many we can get through on this one, but we're changing up what we're doing from problems 1 through 4 to 5 through 12. This one we're not necessarily solving, at least 5 through 10. We're not solving for all the trig ratios. It just simply says, hey, I'm going to give you two pieces of information. I need you to find the third. They say that as find the measure of the indicated angular side. So in this case, what you'll see is we have a side length and an angle, and it's simply saying, it says find the length of side x in this case. The next problem, let's look real quick. Let's look over at number 6. Number 6, they give you both side lengths, and they say, now find the angle. So each of these problems, 5 through 10, gives you two pieces of information and asks you to find the third. So what we need to do is take that information and determine which ratio do we have that we're working with and solve it. So let's do that. We have angle 37, and in relation to the angle 37, we have the opposite and we have the adjacent. So opposite and adjacent, that's tangent. So what I'm going to do is I'm going to write out everything I know. Tangent of 37 degrees is equal to opposite, which is what we don't know, x, over adjacent, which we do, which is 7. Now, to solve this, we need to get x by itself, so we simply take and times by 7, and we get 7 times tangent 37 equals x, because 7 times something over 7 cancels it out or reduces it to 1, and we get x by itself. At this point, I do need you to give me an approximate value. I've had students ask, and it's a valid question. In problems 1 to 4, I stressed exact. Do not leave square roots in there. This, on the other hand, if I type in 7 times tangent of 37 degrees, I will get a decimal approximation, but I do not want you to leave your answer as 7 times tangent 37 and box it in, at least not at this point. So what we do need to do is type that into our calculators, and we find that x equals approximately 5.27. And then we would always make sure we box in the answer that we want checked to see if we're right or wrong. We don't just leave all of our work hanging out there. We have to box in what we consider as our final answer. So see again, now 6 is going to be similar. We have the theta as our unknown, but we have to look at that theta and say, okay, what do we know about our triangle, and what do we know about this theta character? What we know is that we have the opposite and we have the adjacent. What we don't have is hypotenuse. So again, we're working with tangent. Tangent, we're going to say tangent of theta. So now we have our variable here. Tangent of theta is equal to opposite over adjacent, so 13/11. This one's a little bit trickier because, like in problem 5, we need to get the variable by itself, but in 5, we just took both sides times 7 and we were done. This one here, it's inside of a trig function. So what that's going to do, what we need to look at is we need to take both sides, and we need to say that we undo tangent. Just like we undid dividing by 7 in number 5, we undid the divide by 7 by multiplying their opposites. Dividing, you cancel by multiplying. We need to undo taking the tangent of theta. And in order to do that, we take arctan, or tan to the minus 1 is what it looks like. So we take the tangent inverse of tangent of theta. And what we do to one side, we do to the other. Just like when we multiply by 7 on the right side of problem 5, we had to come over here and do the same thing over here. So we're going to do the same thing here and say tangent tan inverse of 13/11. So what we get is tangent inverse of tangent of theta leaves us just simply with theta. And then in our calculators, tangent to the -1 key is it's a key. Give me a second here. What I've just done, I paused the video for a split second. I got my TI calculator emulator pulled up. So we want to find tangent inverse of 13/11. So I'm going to show you what it would look like in a graphing calculator. So that would be the second key, and then because if you look at tangent, right above it in blue would be tangent inverse. So that's tan -1 of that fraction 13/11. Before I hit enter, I am going to go to mode and check. Okay, I am in degrees mode. Right here, I am checking to make sure that that is a darkened background. So second quit gets us back out of that. I'm going to hit enter. So I get 49.76. So that would be the angle whose ratio is 13/11. So 49.76. Again, box that in, and there you have it. So that's the goal here between 5 through 10. If I keep this around a 7-minute video, I will not get through all 4 of these last 4 problems. But what I will do is say that in 7, let me go back to blue. I'll set these up, or at least most of these. When I look at this, I have the opposite and I have hypotenuse. So I know that my setup is sine of 32 because we have opposite and hypotenuse. The sine of 32 is 2 over x. Opposite over hypotenuse. I will go back and I am going to solve 7 just because it's the only difference that we haven't seen. 5 and 6 are very different. One solves a side, one solves an angle. 7 does solve another side, but it does it a little differently. What we have different here is that our variable is on the bottom. So what we need to do, I'll do this as quick as I can. We need to multiply both sides by x. So then we get x times sine of 32 equals 2, because x times x in the bottom reduces those out. And then to get x by itself, I'm going to flip-flop my codes here. So now I'm going to divide both sides by sine 32 and divide by sine of 32. So what we get is sine 32 divided by itself, we get x equals, and then whatever we had left on the right side, which was sine of 32. Now what you could notice is that from start to finish, we just simply took and flip-flopped the x and the sine 32. See, if you look at this, it's very, very similar to what we started with in our trig ratio. We just simply replaced those two, and then we swap places. Anyways, when we do that, 2 over sine 32, we should get about 3.77. And the units are just, it's kind of unitless here. We don't have degrees. We don't know if we're measuring these side lengths in any particular unit. So we say that x is just 3.77, and we call it good. 8 I'll set up, 9, 10 I'll set up, and we'll get out of here as quick as we can. Theta, in this case, we have opposite and adjacent, so this is tangent of theta. 12/13. Again, to undo theta, we take the tangent inverse of 12/13. Because we did that to the left side, we would get theta by itself. And then you find the approximation. Let's see, theta becomes about 4271 degrees. Question 9. 9 is similar to 8 in the sense that we're just setting it up. We have the opposite side of theta, and we have the hypotenuse. So opposite hypotenuse, that's sine of theta, is 3 over 4. If you, again, you take the sine inverse of sine, you get theta. And that should be, I believe, about 48.59 degrees. 10 again is going to be sine. We're given the angle, the opposite of that, and the hypotenuse. So, but the nice thing is this time we're given 46.2 degrees. X is on the top and 10.1 on the bottom. You simply multiply them across. 10.1 times sine of 46.2, you get X equal to about 7.29 units. So there it is. I kind of sped them up at the end, but we've got them all. We will move on to 11 and 12 in the next video.